Hey guys, Mr. Bowman here. Today's learning objective is in green, and we are learning to identify the angle properties of polygons. Before we get into the geometry itself, we do want to kind of develop our understanding, well, what does that word polygon or polygons mean? And there's a couple variations of polygons that I want to bring to your attention, and then we'll get into the geometry related stuff. So the first thing is polygon. That's a fancy way of saying a shape. They can be triangles, they can be squares, rectangles, quadrilaterals, pentagons, octagons, any shape you can think of that is a polygon. And we're going to look at the angle rules of polygons. So we've already done the triangle side of polygons, but let's extend that to 4 sides, 5 sides, 6 sides, 7 sides, 10 sides as well. And there's two variations that I need you to be aware of. There's something called an irregular polygon. And I'll actually draw it down underneath it. That's a polygon where the sides have different lengths. So the sides are not equal. So you may have a couple sides that are the same, but if they all aren't the exact same, they will be an irregular polygon. And that leaves the last phrase, a regular polygon. These are shapes where all sides are equal. And if you think of a square, that's a really good example. All those sides are equal, so I'm going to put a dash to suggest that. Maybe you're thinking of a hexagon like that. All of those sides would be equal, so both of those shapes would be a regular polygon. Today's video will have a big focus on the irregular types because there will be a separate video about regular polygons and how the geometry and the internal angles of that works. So that's the definitions. We can now get into the geometry side of things. So I'm going to draw a couple shapes to assist us. So I'm going to draw a triangle. We've already looked at a triangle, and we're going to assume everything is an irregular polygon, that they're all slightly different. And then maybe we'll look at a rectangle, also known as a quadrilateral. And then finally, well, let's have a look at that hexagon that I mentioned as well. So we're going to assume all of those are different sides. It's not a regular hexagon. It's just got 6 sides. So the starting point I want us to look at was how many triangles are there in each of these shapes? Well, given this one here is a triangle, we can pretty confidently say that there's only one triangle there. And we know that triangle, all of those internal angles, we know that they were going to sum to 180 degrees. Well, then let's have a look at the square. And the thing I want you to focus on is how many triangles are in the square. So we're going to use the triangle as like a base shape to construct all the other shapes. So if you start at a corner here, and so we're going to pick a corner, and the idea is we want to go to any corner that's not already attached to that point. So we can't go this way because it's already attached. We can't go this way because that's already attached. But we can go across to that corner because they're not attached. And that's all the corners. They're all now attached to that one corner. So that tells us that there's going to be 2 triangles within that shape. And if there are 2 triangles, well, the internal angles is actually going to be 180 times 2, which tells us the internal angles of that shape would be 360 degrees. And if you do think about it, that makes sense because in a rectangle, you would actually have 4 90-degree angles. And 4 times 90 does get us to 360 as well. So happy with that. And the last one we're going to look at is we're going to have a look at this hexagon, a regular hexagon that is. So this is the point we're going to use. So it's already connected with that corner, so we don't have to worry about that. It's already connected with that corner, so we don't have to worry about that. But we do have to worry about the corner over there, the corner over there, and the corner over there. So let's connect those. Connected, connected, and connected. So we can now see every corner is connected to our friend over here, or this one. So don't forget, we're only picking one corner to do that connections with. We now can count up how many triangles there are. Well, there's 1, 2, 3, and 4. So there's 4 triangles in that hexagon. So 4 triangles. So that means the internal angles of that shape is actually going to be 180 times 4, which comes to 720 degrees. So we'll be able to calculate. So if we've been given some of these angles, maybe we're given all of them but one, we can go ahead and calculate the one using that rule. So what I want us to do is, we've looked at 3 specific shapes. I'm just going to show us a rule that will work regardless of the shape, so you can stop breaking it into triangles, and we're going to focus on a formula that'll help, because I love a good formula. Okay, so we switch to the blue pen, and basically what this is saying is there is one triangle which is 3 minus 2, if I'm not mistaken. So that gets us to that one triangle part. We're then going to multiply that by 180, and that gets us to that 180 degrees that we figured out before. So the key thing here is that minus 2. So if you have a look again, this one has 4 sides and 2 triangles. So again, there's been a minus 2 happening. So that's 4 minus 2 times 180. And yep, that gets us to our 360 degrees that we suggested before. And finally, this hexagon, it had 6 sides. So we're going to go 6. We're going to take away 2. So we've done that for every part. So we've done that for every part. We're going to times that by 180. So that's going to be 4 times 180, which gets us to that 720 degrees again. So that there, we've kind of developed a little rule that's going to help us. So we're going to say that n is equal to the number of sides. So if you can count up the sides, you can say that the total internal angles, they're going to be equal to 180 degrees times the number of sides minus 2. So we'll be able to use that formula instead of breaking it up into the separate triangles. Okay, so we're then going to get into some questions just to demonstrate, well, how does this work? So let's say I've got a weirder 4-sided shape. Maybe it looks like this. Well, that's not poorly drawn. Let me draw that again. I want to do better than that. Okay, so let's say I know that this one here is 30 degrees. I know that one there is 20 degrees. And let's say I know that one is a right angle. You'll be able to use that to figure out that missing angle in the middle. So the first step would be, how many sides are there? So we've got 1, 2, 3, 4. We've got 4 sides. So if we apply that to a formula, so total internal angles is equal to 180 degrees, 4 minus 2. So that actually was similar to the rectangle that we looked at before. So that's going to be 180 times 2. So that means the total internal angles of that shape must add up to 360 degrees. So we can form a bit of an equation there. So we know that 30 plus 30 plus 90 plus x, all of those should combine to get to 360. So all those numbers, they add up to 150 plus x equals 360. And hopefully you're getting the same, but x should equal to 210 degrees. And you're always going to be asked to show some geometric reasoning for that. And I like to reference the number of sides and how I explain it. So I'm going to write my reasoning down here. So internal angles of a 4-sided shape must sum to 360 degrees. So I've done my working and I've got a geometric reasoning. In a test or an exam, I'd be really happy with that response. And we can also be a bit more algebraic with how we go about this. So let's randomly create another shape. So let's say the shape looks like this. It's going to be a weird shape. So we've got a shape like that. So let's say this angle here is going to be 1/2 of x. That angle there is x. And that angle there is x. So let's say we don't know any of those. But we do know that those two angles are 250 degrees. And we know that that angle there is 90 degrees. So it's a weird shape. And the one that we also know down here, we're going to say that's also 80 degrees. So we can actually use that information. Even though we don't know 3 angles, we should be able to figure them out. So let's have a look. How many sides are there of the shape? So there's 1, 2, 3, 4, 5, 6, 7 sides. So we've got 7 sides, which means it's going to be 180 times 7 minus 2, which is 180 times 5. And that there is going to be 900 degrees. So all of those angles that we listed, they must add up to 900 degrees. So we are going to put in all the numbers we know. So we know that 80, which was this angle here, plus another 80, which is over here, plus 250, plus 250. Those were those two angles there. And we know if we add 1/2 of x plus x plus x, we know that must combine to get 900 degrees. We are running out of room, but we'll carry on with this. So we know all of that. That's going to be 2.5x plus 660. Well, that's going to be equal to 900. So that means 2.5x is going to be equal to 240. So if we finish off our working down here, x will be equal to 240 divided by 2.5, giving us a value of 96 degrees. And in terms of reasoning, quickly finish up our reasoning because it is important to have it. So we'll be able to say internal angles of a 7-sided shape must sum to 900 degrees. So that wraps up our video. I know our screen looks a whole lot of mess at the moment, but we did go through the definitions of polygons. We went through, well, how do you get to the formula? How do you break shapes down into triangles? We then developed our own formula, so we don't have to break it down into triangles every single time. And then we looked at 2 scenarios, one where we were given all of the angles except for one, and one where we had to develop a bit of an algebraic equation to find out a missing value, or x. So hopefully you found this video useful. Let's practice this. Let's get into heaps of questions.